The OneAdvisor 800 features Ethernet traffic generation and analysis at rates up to 800 gigabits per second. This video will cover the Layer 2 traffic test, which is a standard feature for all Ethernet options on OneAdvisor 800s with transport hardware. The test can be used to verify network connectivity to local switches, loop back traffic to another test instrument, discover, loop up, and loop down other Viavi instruments, generate traffic, and analyze network performance in real time. Key performance indicators include throughput, frame loss rate, bit error rate, delay, jitter, committed burst size, and service disruption time. In this video, I will present basic features at 1 gig and 10 gig. In part 2, I will present advanced features at 100 gig, 400 gig, and 800 gig. First, I will demonstrate how to configure a OneAdvisor for loopback. I have a copper SFP in port 1 of a transport module connected to an Ethernet switch. I have powered up a OneAdvisor. From the home screen, I will tap Tests to display the test menu. Tap Transport to display the transport test application and tap the transport icon. I can now launch the test with a single tap on my pre-configured favorite tests or from the Select Test menu. I'll use the Select Test menu and choose the Ethernet 10-100-1000 Layer 2 traffic test on port 1. The user interface includes the menu bar from which I selected the test, a message box, a quick configuration bar, a panel with LEDs, icons to select alternate panels, 2 results windows, an action panel, and a column of soft keys. The LEDs show that my link is active. The quick configuration shows default settings for auto negotiation, test mode, and frame size. In most cases, the OneAdvisor can activate a link and loop back traffic with the default setup. On 10-100-1000 meg copper and 1 gig optical interfaces, auto negotiation may need to be changed. It defaults to on, but if auto negotiation is disabled on the line under test, you can turn it off in the quick config. Auto negotiation and other settings can be configured in the setup menu, but defaults are recommended for loopback. If you don't know whether settings are at default, you can press Reset Test to Defaults in the Tools menu. The 2 results windows are both showing results in the Summary group. Summary status is color-coded red due to a short period of sync loss and link loss while the link was being established. The Restart soft key clears the alerts. The status screen will remain yellow until test packets are received or an error occurs. To verify that I'm on the correct switch port and VLAN, I will change the group of my rate results window to Ethernet and change the category to LLDP. I can see that I'm connected to switch port GI1 and the VLAN ID is 1. I'm ready to be looped up. I could manually loop up by tapping LLB, but the OneAdvisor will automatically loop up and loop down on receipt of commands from another Viavi instrument. When looped, the OneAdvisor will retransmit all received test packets after swapping MAC addresses. Now I will demonstrate Layer 2 traffic generation with a 1 gig optical SFP on port 1 of a spectrum analyzer module with optical hardware. The SFP is connected to an SFP on the same switch as the OneAdvisor loopback device. Both ports are on VLAN 1. I will verify a committed information rate of 500 megabits per second to the loopback device. I have powered up my OneAdvisor. From the home screen, I will tap Tests to display the test menu, tap Transport to show the transport test applications, and tap the transport icon. My Select Test menu is hidden, so I'll tap All Tests to unhide it. In the Select Test menu, I'll tap Ethernet, 1 GigE optical, Layer 2 traffic, and terminate. The user interface is the same as the 10-100-1000 user interface, with the addition of laser controls. With the default setup, the OneAdvisor will generate constant line rate traffic. The traffic will be untagged, 512-byte frames, as can be seen in the quick config. Let's take a look at setup options. In the interface settings, I see information about the optical transceiver. I'm using a 1310 nanometer SFP that supports both 1 gig and 10 gig Ethernet. I can also see the minimum and maximum transmit levels and receive levels to assess if optical attenuators are required. Auto negotiation settings can be set in the Physical Layer tab. In the Ethernet settings, I can configure the test packets. I will set encapsulation to VLAN. Frame type DIX is recommended to simulate IP traffic. The frame size for VLAN tagged frames can be anywhere from 68 bytes to 16,000 byte jumbo frames. I will select EMIX for multiple frame sizes. Destination address and source address can be left at default. The OneAdvisor will broadcast a loop-up message to discover the MAC address of the Viavi loopback device. Under the VLAN field, I will set my VLAN ID to 1. I will leave other fields at default, although the ether type for the test packet could be changed under type, and the transmit payload of the test packet could be toggled in the data field. The default Acterna payload contains sequence numbers and timestamps to measure frame loss and round-trip delay. On to the traffic settings. You can select 3 load types: constant, burst, or ramp. I'll use constant to measure throughput, frame loss, round-trip delay, and jitter under a constant load. The load can be specified as a bit rate or percentage of line rate. I'll configure a load of 50% to verify a committed information rate of 500 megabits per second. The results key will return me to the results screen where I can run the test. The LED and summary status window indicate that the link is not active. In the first tab of the action panel, I'll start the laser, and I'll tap Restart to clear the error history. In the second tab of the action panel, I can loop up the far end OneAdvisor. My message panel indicates the loop up was successful. I can now start traffic and view results. My rate results window shows key performance indicators. I'm receiving the 500 megabit per second committed information rate back from the loopback with no frame loss, low delay, and low jitter. I can also view an event log. Interface results, Ethernet statistics, and graphs. When the test is complete, I can save these results to a report by tapping the reports icon and create report. I can edit the file name, specify the format, and choose the contents of the report before I create it. I will use the same setup to demonstrate service disruption testing. In setup, The Service Disruption tab lets me enable service disruption testing. Threshold time is the duration that triggers a service disruption entry, while separation time is the duration for which the link must recover before a new service disruption is logged. In the Event Triggers tab, I can define what events trigger a disruption. I will select interframe gap. No traffic for 0.5 milliseconds will constitute a disruption. Back in Results, I will reset my interframe gap in the third tab of the Actions panel. I can see this value at the bottom of the Ethernet Layer 2 link stats. I'll trigger a service disruption on the loopback device. Peak interframe gap is now over 300 milliseconds. In the Summary Results category, I can view a summary, details, and statistics regarding the service disruption. I will now stop traffic and loop down the far end device. I will now demonstrate Ethernet bit error rate testing, or BERT. I will also introduce time tests, ramp testing, and dual port testing with a 400 gig transport module. I have 10G base LR4 SFPs in both ports of a transport module and a duplex LC patch cord between them. First, I will launch a Layer 2 traffic test on port 1, turn on the laser, and use the default settings for loopback. There are two ways to add a test on the second port. I can tap the plus sign at the top of the screen, or in the Select Test menu, I can tap Add Test, Ethernet, 10 gig ELAN, Layer 2 traffic, port 2 terminate. I will tap Setup to configure the test. In the Ethernet settings, I will configure the format of the test packets. I will set frame size to 1518. Destination address and source address can be left at defaults to discover and loop up a Viavi instrument. In the data field, I will set transmit payload to BERT. Back in the interface menu, Physical Layer tab, I can now set an error count or error rate threshold for the test. In the traffic settings, I will set the load type. Bit error rate tests are typically run at constant rate, but I'm going to choose ramp and leave other settings at default. The load will increase by 1% every minute until an error occurs, a pause frame is received, or line rate is achieved. In the time test settings, I will set test type to timed test and duration to 15 minutes. I will tap the checkbox to automatically create a report. Back in Results, I will start the laser to activate the link and tap Restart to clear the error history. In the second tab of the Action panel, I will loop up port 1. My message panel indicates that the loop up was successful. Tapping Start Traffic initiates the ramp test. In the fifth tab of the Action panel, I can insert a few bit errors to verify that they are looped back and that my error rate threshold triggers. Let's take a look at a few more results. Summary Event Log lists and timestamps all errors and alarms. Summary Time shows the test time remaining. Ethernet BERT stats shows my bit error count and bit error rate. The throughput graph shows the ramping process. I can also graph errors. Restart will clear results and reset the test time to 15 minutes, after which a pop-up window lets me edit the file name, select the file type, and choose the report's contents. Finally, I will stop traffic and loop down the far end device.